One of my main goals for this school year was to increase the number of inquiry-based learning opportunities for my students. My students now create and complete their own studies on the variables which influence cell respiration in yeast, photosynthesis in fast plants, design and construct earthquake-safe structures and roller coasters, and engineer and build balloon cars from household trash. At the beginning of this school year, only 53% of my students could properly identify an independent variable. Only 15% could properly identify the dependent variable. After completion of several of these inquiry-based hands-on activities, almost 90% of my students could properly identify both variables. Each of these activities follows a similar framework. First, the project is introduced. The project information is organized into a bundle within my big campus. They also build background knowledge through traditional classroom instruction, but they also use self-directed exploration of media-rich content via the digital textbook from Discovery Education, as well as web-based simulations. Students are then given a list of materials that they can use to develop their own experiment to explore and a hypothesis to test. This allows students to take more ownership of their own learning and drives new forms of productivity and value creation. Students then refine their hypothesis, collect data, and analyze their data. A classroom culture where mistakes are seen as learning opportunities and not failures helps my students to refine the scientific process. Once the project is done, students then summarize their learning into a conclusion and share it with others. The effective use of technology, this self-directed process of learning science, provides my students a lifelong intellectual process for gaining meaning and understanding across all subject areas.